All right, good morning, everybody. Hope you guys are doing well. Today I'm going to go over the practice problems from 519, which was page 397, 20, 24, 30, 33, 40, 46, 50, 58, 60, and 62. So let's get started. So starting with number 20, the directions for number 20 actually all the way up to number 40 and any of the ones in between there it says in the exercises, it says solve the exponential equations algebraically and then approximate the result to 3 decimal places. So number 20 starts out with 4 e to the x equals 91. And so the way we're going to do that, we're going to get rid of the 4 first by dividing both sides by 4. And then we're going to be left with e to the x equals 91 divided by 4. And following that, there's a couple ways you could proceed. You could either take the natural log of both sides, or you could convert it from exponential to logarithmic form. I'm just going to take the natural log of both sides. I think that's a little more straightforward. And now you can see on the left-hand side you have natural log of e to the x. Now the power property allows you to bring the x down, like that, and then natural log of e cancels. So you're left with x equals natural log of 91 over 4. Now when you actually type that into your calculator, you take 91, you divide it by 4, you get 3.125. That's rounded to 3 decimal places. Okay, the next one. 24 is 4 to the negative 3t equals 0.10. So for this one, since there's nothing else with the 4 except for the negative 3t is part of the exponent, you're going to take log base 4 of each side. So we're going to take log base 4 of 4 to the negative 3t, and that's going to equal log base 4 of 0.10. Now from there, the negative 3t can come down, and you're going to have log base 4 of 4 equals log base 4 of 0.10. The log base 4 of 4 cancels. You're left with negative 3t equals log base 4 of 0.10. And then from there, we're just going to divide both sides by negative 3. And so we'll have log base 4 of 0.10 over negative 3. Now remember, you'll have to use the change of base formula to type that in your calculator. So what you're actually going to type in is going to be parentheses and then log of 0.1, then close your parentheses, divided by log of 4, close out the second set of parentheses, and then you're going to divide all that by negative 3. And when you do, you get 0.554. All right, moving on to number 30. Number 30 is 1,000 e to the negative 4x equals 75. So we're going to start by dividing both sides by 1,000. So we'll have e to the negative 4x equals 75 over 1,000. Now that will reduce 75 over 1,000. That's going to reduce to 3 over 40. Now, the next thing we're going to do is we're going to take the natural log of both sides. So let's do that. And again, the reason why we're doing that is that allows us to bring this 4x down using the power property. And from there, the natural log of e cancels. So you're left with negative 4x equals the natural log of 3 over 40. And so x is the natural log of 3 over 40, all divided by negative, I'll have to scooch this up before a little bit, all divided by negative 4. And so you type that in your calculator. You've also got to use the change of base. So you've got to do natural log of 3 divided by natural log of 40. And then from there, you're going to get an answer, and then divide that by negative 4. And when you do, you get negative 0.074. So that was number 30. The next one we're going to do is 33. And 33 says we have 6, 2 to the 3x minus 1 minus 7 equals 9. We just got to start peeling away the layers. We're going to start by adding 7 to both sides. So you're going to have 6, 2, 3x minus 1 equals 16. Then we're going to divide both sides by 6. That'll be 16 over 6. Now 16 over 6 will reduce to 8 over 3, which is what I'm going to do next. Now I'm going to take log base 2 of each side. Hopefully you're catching on to how I'm choosing which log I'm using on both sides of the equation. The log that I'm using on both sides of the equation is always going to be log base whatever the base is of the exponent. And so this 3x is going to be allowed to come down, and you can see this log base 2 of 2 cancels. So you're just left with 3x minus 1 equals log base 2 of 8 over 3. Now from there, I've got to add 1 to both sides and then divide everything by 3. So 3x equals log base 2 of 8 over 3 plus 1. No, you can't combine them because you'd have to log 8/3 first before you add 1. And then the last thing we would do is we are going to divide by 3 everything. So it's log base 2 of 8 over 3 plus 1, all of this divided by 3. Now, give me 1 second to type this into my calculator. You're going to take parentheses, then you're going to have to do log of 8 divided by 3. And then that log gets divided by log of 2. And then from there, you're going to add 1 to that. And I would suggest just getting that answer and then taking that answer and dividing it by 3. And then you'll end up with x equals 80. It's going to be 0.805 for 33. All right, now moving on to number 40. If you look at number 40, it says e to the 2x minus 5e to the x plus 6 equals 0. And now what you're going to do with this one is you are going to actually pretend like it's a quadratic, and we're just going to do a quick substitution. We're just going to say this is x squared minus 5x plus 6. Okay, we actually don't need a parentheses there. Equals 0. Now, the way that would factor is that would factor into x minus 6, x plus 1. And so this right here is going to factor very similar, but instead of the x, that is actually going to be e to the x. So this one is going to turn into this x right here and this x right here are going to get e to the x substituted in for them. So it becomes e to the x minus 6, e to the x plus 1 equals 0. And now from there, each of these gets set equal to 0. So e to the x equals -1, and e to the x equals 6. Now over here, I'm not sure if you recognize that, we're going to take natural log of e to the x equals natural log of -1. But when we do this, natural log of -1, if you try to do that, you're going to get an error. So this one is no solution because you can't take log or natural logs of negatives. This one, you're going to take natural log of both sides. And then the natural log of e cancels, and you're left with x equals natural log of 6. And natural log of 6 is 1.792 approximately. Okay, give me 1 second here. All right, so now moving on to the next one, number 46. Number 46 says you have natural log x minus 7 equals 0. And it says solve the logarithmic equation algebraically, approximate the result to 3 decimal places. So this one's pretty easy. You're just going to have natural log of x equals 7. From there, since you're logging the variable, you're going to switch it into exponential form. So remember, the base of natural log is e, so it just becomes e to the 7 equals x. And that's going from logarithmic form to exponential form. And then you can type that into your calculator. The e to the x button is above the natural log. So if you hit second natural log, you'll get an e to the x. And just write e to the 7th. And it is, x is about 1096.663. That's supposed to be a 9. So that's number 46. Now the next one after that, number 50. Is natural log of the square root of x minus 8 equals 5. Trick with this one, anytime you have square root, cube root, whatever, first thing you want to do is you want to move those out of being a radical and make them a power. So the square root is actually the 1/2 power. Now, following that, we need to get rid of the 1/2 power before we take it from logarithmic form to exponential form. So we can use the power property and move that down. And then we're going to have to divide both sides by 1/2, which is the same as multiplying both sides by 2. So we're actually going to get natural log of x minus 8 is equal to 10. Now from there, we're going to convert it into exponential form. So that's going to be e to the 10th equals x minus 8. And then we're going to add 8 to both sides. And so we're going to get x equals e to the 10th plus 8. Now when you type that into your calculator, you get e to the 10th. And then we have my plus 8. You get 2203.47. That's the answer to number 50. The next one after that is number 58. Number 58 is the natural log of x plus 1 minus the natural log of x minus 2 equals natural log of x. Now we're going to utilize the quotient property first. We have two things that are being logged, and so we can combine those into one natural log, like this. And then from there, you can see we're going to utilize the one-to-one property, because if those natural logs are truly equal to each other, then the expressions themselves have to be equal. So we're going to set this right there. And then we're going to cross multiply this. So put this over 1, cross multiply, x plus 1 is equal to x times x minus 2. And so x plus 1 equals x squared minus 2x. Now we're going to move all the stuff over to one side. So So we have x squared minus 3x minus 1. And then from there, we would have to utilize the quadratic formula to solve this, since it won't factor. And so to do that, it's going to be negative b, so negative of negative 3, plus or minus the square root of b squared minus 4ac over 2a. And so that's going to give us 3 plus or minus 9 plus 4 over 2. And one more simplification, it gives us 3 plus or minus the square root of 13 over 2. And so when I type that into my calculator, 3 plus the square root of 13 divided by 2, bear with me for 1 second, it takes me a second, you are going to get x equals 3.303, and then when you type in 3 minus the square root of 13 over 2, you get negative 0.303. Okay, guys, we're almost there. We have number 60. Number 60 is log base 2 of x plus log base 2 of x plus 2 equals log base 2 of x plus 6. So this one is also going to utilize one of the other properties. This one's going to utilize the product property, and because you have a log here and a log here, those can be combined. So you're going to have log base 2 of x times x plus 2 equals log base 2 of x plus 6. And so now you can see, since they're both log base 2's, we're going to set this equal to this. So we're going to have x times x plus 2 equal to x plus 6. So this becomes x squared plus 2x equals x plus 6. I'm going to subtract x from both sides and subtract 6 from both sides, and we end up with this expression. This is actually factorable into x plus 6, x minus 1, and so you get x equals negative 6 or x equals positive 1 for that one. Okay, so the last one, number 62, is log 8x minus log of 1 plus root x, and that's going to equal 2. First thing we're going to do is we're going to utilize the quotient property to combine the two logs on the left-hand side. So it becomes log of 8x over 1 plus root x equals 2. Now the next thing that we're going to do is we're going to take this from logarithmic form and we're going to put it into exponential form. So since the log doesn't have a base listed, it's base 10. And remember, it's going to be the base and then the other two parts switch. So it's 10 to the second equals 8x over 1 plus root x, like that. Now, we've got a little bit of cleanup work to do, and you'll see why here in a second. But this first is going to turn into 100 equals 8x over 1 plus root x. From there, we're going to cross multiply. So we can make this 100 over 1. And so we'll have 100 times 1 plus root x equals 8x. And now we can reduce. The 100 and the 8 are both divisible by, they're actually divisible by 4, so let's reduce them more. So 100 will go in, 4 will go into 125 times. and 4 we're going to 8x twice. So that gives us this. Now, this is where it gets a little bit trickier. So the 25 needs to be distributed. So we're going to have 25 plus 25 root x equals 2x. And the biggest thing here is that the root x is an issue. We need to solve for it. And the only way you're going to get rid of that square root is by squaring it. So we're going to end up having to square both sides of this equation. But before we square both sides of this equation, we want to get this 25 to the other side. And so we're going to subtract 25. So we're going to end up with 25 root x equals 2x minus 25. And now from here, we're going to square this, and we're going to square this. Now you're allowed to do that as long as you're squaring both sides, which we are. So this turns into 625x. And see, that accomplished getting that square root out of there. Now on the right-hand side, when we square that, I'm going to save you the foiling, but what it will turn into is 4x squared minus 100x plus 625. Ran out of room there. That's 625. Sorry about that. And now the 625 on the left-hand side needs to be moved over to the right-hand side. And so when we do that, we're going to subtract it. We get 0 equals 4x squared minus 725x plus 625. And so now we have a pretty large coefficient quadratic equation that you would use the quadratic formula to solve. And so you would set that up as negative of negative 725 plus or minus the square root of 725 squared minus 4 times 4 times 625. All of that over 2 times 4. Now, when you actually go to type that into your calculator, you'll end up with two answers. Well, let me give you the two answers. The first answer is x equals 0.866, and the other one is going to be x equals 180.384. But anytime that you square both sides of an equation, and this is something that you guys probably learned back in Algebra 2, but it's been a long time, which I understand, so I want to go over. Anytime you square both sides of the equation, like what we did up here in this step right here, it can create something called an extraneous solution. And when you have extraneous solutions, what that means is you did everything algebraically right, but the solution, when it's plugged back into the equation, doesn't actually work. And that can happen when you square both sides of the equation. So if you ever have to square both sides of the equation in solving a problem, you always need to go back and plug both of your answers into the original equation to see if they work. And if you do that with this, what you'll find out is this solution right here is extraneous. It actually will not work if you plug it back in. So the only solution to number 62 is that one. So, all right, there you go, guys. I know these were a little tougher than the last couple days. So hope you guys are doing well. Talk to you soon.